Hey guys, I'm going to talk about how I wired my Fadal CNC machine for single phase power without using any additional transformers. So this comes up quite a bit on the forums, and I just figured I'd try to make an explanation to help people out. Now, this is very much just a rough outline of how you do it. It's not going to be step-by-step instructions, and part of that a lot depends. It depends on whether your machine's AC or DC, what sort of spindle drive you have, rigid tapping, when your machine was built. There's differences between a lot of machines, and so it's not one size fits all, where somebody will say something works and yeah, that applies to their machine, but it might not work on your machine. So this is very much just about how I figured it out for my machine, and you can go through these same sorts of steps and look at your machine and hopefully figure it out how to do it for yours. Um, this is the transformer that you can buy that was an accessory that would convert a three-phase machine to single phase. They're expensive, they're hard to get, and you don't really need one. And I'm going to show you why you don't. Certainly, this can make your life easier. There's actually some instructions about how to use it, but if you're clever and you read the manuals and you look at the diagrams, you can figure out how to do it for yours. Now, this very much assumes that you have 240 split phase power to supply your machine with. This means that you have two lines that between them make 240 volts, and then you have a neutral, and then from that you get two 120 volt supplies. And if you don't understand this, you should probably step away from your machine slowly, but I'm going to be talking about 240 split phase a fair amount, so I just wanted to bring up that this is what I'm talking about. Like I said, you're going to really need to look at the manual. This is a great site that has a lot of them. Pour yourself a glass of wine, put on some nice music, and stare at your machine and stare at all these wiring diagrams until you really understand your machine. And this is the diagram that helped me the most. It's not totally accurate for my machine. My machine seems to be made before this diagram, but this is a good way to kind of see the big picture of what's going on for power supply in the back of your machine. You have main power that comes in, that comes to this terminal block, and from there, there's three main groups of things that need power. You have your sort of logic boards here, you have your amplifier here, and you have your spindle inverter here. And so the game you need to play is I need to make these three things happy with the right kind of power and understand what kind of power they need and make them from my power supply that I have available, i.e. 240 split phase power. So let's start first with the easiest one, which are these two like logic boards. I'm honestly probably not the best one to tell you what these exactly do, but I'm going to call them logic boards. But yeah, we need to make, and we can see here from our diagram, we need to make 120 volts AC for each of these. And that was the case on my machine. I verified that that was the case the way my machine is wired. And so what we're going to do is looking at our 240 split phase, we have 120 available. If we just go from the neutral to one of the lines, we can make 120. And so going back to this diagram, I brought in line one and line three, and that's 1 to 3 makes 240. But instead of line two being a third phase, this is my neutral now. So this actually acts as my neutral. And instead of being disconnected, I brought it into the machine. And then if I go between here and here, line one to my neutral, I get 120. And so that's how I connected these two I guess we call users consumers of power, and gave them 120 volts. Okay, next, let's talk about the inverter. Uh, Different machines have different inverters. Mine was the old Mitsubishi inverter. This inverter turns out will not run on single phase. Some of the other inverters you'll see people talk about in the forums, you can just get away with like leaving one of the phase disconnected, supplying them with single phase, and the inverters are fine. But mine was the wrong kind of inverter to do that, so I needed to find a new inverter. Uh, Nowadays, in modern technologies, inverters have been largely replaced by variable frequency drives, and so what we need is a variable frequency drive that will take our uh, supplied power here and generate three-phase output to the motor. And so this is what I bought, was just this cheap Amazon 20 horsepower. I mean, cheap, relatively cheap, $500. Um, I've used the 20 horsepower option, and this takes single phase, and it's going to generate three phase power out to the motor. You can program this, and it has the right logic inputs to understand the controls that the machine puts out to control the VFD. I'll talk a little bit about that, but you can read up on it. You can look at how your VFD is wired. You need to read the manual for how your VFD is done, but you can set this up if you don't have rigid tapping. Rigid tapping you can still do, but it's even more complicated. But anyways, you can wire this in, and this becomes your spindle drive. Okay, last thing is the amplifier. This was the hardest thing to figure out because my machine is a 94 machine and seems to be not reflected on a lot of the diagrams on how it's actually powered. And so looking at my machine, uh, timeout, I got to pull up a manual. I'll be right back. All right, I'm back. Sorry. I needed to pull up the maintenance manual, section 6, access drive. Um, and so looking at this manual, I noticed it mentioned that the input power to the access drive system on some machines was 86 volts AC three phase. Uh, could be 120 volt single phase, could also be three phase. Um, yeah, but looking at my machine, I was pretty convinced that it actually uses 86 volts AC single phase. Um, don't tell me why. It was a long time ago. I forgot how I figured that out, but I think I looked at the machine. I looked at the manual for the Glentech amplifier, and then I also kind of looked at this diagram here. So this diagram here shows different versions of the amplifier chassis for DC that existed at different times. And mine is the bottom one here, which is the oldest one. They clipped off the label, which is not very helpful. But you can see here it says power input, 86 volts AC, three phase. But like I said, looking at my machine, I knew I was going to actually be 86 volts single phase. But long story short, you're going to have to look at your amplifier and figure out what it wants for power in and then make it. So going back to split phase, we have 120, we have 240, but we don't have 86 volts AC. So I bought one of these 20 amp variable transformers, set it to 86 volts, and then use this to generate the 86 volts AC to my amplifier system. So going back to this, uh, now we've basically talked through successfully how we go from the 240 split phase, and we just have to power these three different groups: the logic system, the inverter, and the amplifier. And if you can do that, you're good. One last note is you notice here how there's two different 120 volts. I have my logic on one of the 120 volts, and I have my amplifier system being driven off the other one, just to kind of share the load. So you'll want to do that. Don't just put everything on one of the 120 volts. So next, I'll go over to the back of my machine and just show you a little bit of what this looks like retrofitted into the back of my machine.
All right, apologies. I'm inside my machine here. I'm up against the wall, so it's hard to get a very good angle here, but I'll try to talk to what's going on inside here. So think about you've got 240 split phase coming in. That goes to this terminal block here. Now, these terminal blocks used to be the transformer terminal blocks and the taps for the transformer. Most of that's disconnected or non-functional, but I'm just still reusing these terminal blocks to make connections. So in comes the 240 split phase into this terminal block, and then there's various jumpers to send that power out to the different subsystems. So subsystem 1 is the spindle inverter. You can see here I have a new spindle inverter. This is just a cheap one off of Amazon or whatever. It's 20 horsepower. It's been reprogrammed. It is a single phase to three phase frequency drive, VFD. You can look up how the old one was wired, but basically inside of here, you'll see there's power coming in, power going out to the motor, and then the signal wires that the machine uses to command the spindle drive, and then you have to program your spindle drive correctly On this machine, it sends 0 to 10 volts for the speed that it desires as an analog signal, and then there's a couple wires that signal the direction, and then there's a wire for the alarm. So this has been programmed and set up to work like the old spindle drive used to, but this is a single phase to 3-phase unit. Some of the machines come with VFDs that can use single phase power in. You just leave one leg disconnected. Mine was one of the Mitsubishi drives. It wasn't that case, so I had to do this. All right, next subsystem is the DC drives for the axes. So this is a variable transformer. I couldn't find one that was the correct voltage that I needed. This is set up to be 86 volts to the DC power supply. I don't know why it's 86, but that's the weird AC voltage that it needs. The machine's off right now, but you'd see actually 86 volts on this screen. It's on. I replaced the fuse with a slow blow fuse, and I rewired this here, but there's basically ground and then the 120 volt in, and then a 86 volt out. That comes down to this terminal block here, and that's jumpered over to the DC drive. And then the final thing that needs power is the logic of the machine runs on 120 volts, and so that's on the other phase. So one phase of the 240, aka 120 volts, is driving the variable transformer up here, and then the other one is jumpered over to the logic and the computing side of the house there. So that's a quick look inside my machine. Obviously, that's just to get you started. There's a lot of details here, but hopefully that helps you.